Hey dear viewers, welcome back to this YouTube channel. If you have ever struggled to convert complex numbers from rectangular form to polar form, today is your day. Watch out up to the end of this video, because by the end of this video, you'll be able to convert any complex number quickly, confidently, and without common mistakes. Let's dive right in. To begin our conversation, as a quick summary, as a quick overview of what we are going to discuss, we are going to look at specific examples of complex number that lie in the second, third, and fourth quadrant. Remember, for a complex number that lie in the first quadrant, we did show you an example in the previous video. So, by the end of the session, we're also going to show you how to convert a complex number from polar form to rectangular form. Let's dive into the first example, which is z equals to minus 4 plus 4. Minus 4 plus 4. The first thing will be for you to sketch the complex number on an Argand diagram. Here is the real part, or the real axis, and here is the imaginary axis. Our real part is minus 4, so it can lie here, and the imaginary part is 4. So this implies our complex number is somewhere here. This lies in the second quadrant. So we go ahead and find the argument. Remember from our previous video, the argument, or what we can call the reference angle, is given by arctan of y over x. Remember, the trick here consists of not using the negative value. Use the positive values of both the real part and the imaginary part, which is here arctan of 1 divided by 1, which is pi over 4. Now, remember, from our knowledge of trigonometry, we have angles in the second quadrant given by pi minus pi over 4. So the answer here will be 3 pi over 4. This is indeed our principal value, because it lies in the interval minus pi. Therefore, this is the angle we are going to use in the polar form of the complex number. We now need to compute the modulus. From our previous video, we did mention that the modulus is obtained by having the square root of x squared plus y squared. In this case, we are going to have the square root of 4 squared plus 4 squared. Okay, so the answer here is 4 root 2. So no matter the positive or the negative value of either the real or the imaginary part, because the square of any negative number is positive, that's why we just decide to choose the positive part of either the real and the imaginary part. So we're going to have 4 root 2. Therefore, our complex number in polar form will be written as 4 root 2 times cosine of 3 pi over 4 plus I sine 3 pi over 4. Nice and simple, right? Let's move on to the second example. We have z equals to minus 1 minus I. Once more, we begin by drawing or by sketching. In which quadrant does this complex number lie? We have the real axis here and the imaginary axis here. Minus 1 for the real part can lie here, and minus I, or minus 1 for the imaginary part, can lie here. So you can see this complex number lies where? In the third quadrant. So we'll move ahead and find what we call the reference angle, or an argument to that complex number, which is arctan of the positive value of y and x, y divided by x. So we're going to have arctan of 1 divided by 1. Okay, therefore we're going to have pi over 4. From our knowledge of trigonometry, angles in the third quadrant are given by pi plus pi over 4, right? So we're going to have 5 pi over 4. But remember, this is above pi. It lies above pi. Therefore, we're going to use the formula that was given to us in one of our previous videos, whereby the principal value that we use in our polar form is indeed given by 5 pi over 4 minus 2 pi. We can't say plus 2 pi because simply if you say by 2 pi, it's going to move very far away from pi. So if you do this, we're going to have minus 3 pi over 4. And this lies in the interval minus pi. So we can use that principal value. Therefore, we can now use our formula for r to obtain the value of our modulus, the square root of x squared plus y squared, which is equal to the square root of what? 1 squared plus 1 squared. And the answer is the square root of 2. Therefore, our complex number in polar form is given by the square root of 2 times cosine of minus 3 pi over 4 plus I sine minus 3 pi over 4. Okay? Now, let's look at the third case. And this is the case whereby our complex number lie in the fourth quadrant. We have the real axis here, and we have the imaginary axis here. We have 3 can lie here. We have 4 can lie here. Minus 4 can lie here. So we can have our complex number like this that lie in the fourth quadrant. Remember, angles in the fourth quadrant are measured in the clockwise direction. And when we measure an angle in the clockwise direction, it takes the negative value. So before then, we use our normal formula to obtain the argument or the reference angle to be equals to arctan of y over x. Once more, don't fall into the trap of using the negative value. Use the positive value first, which is arctan of 4 over 3. And the answer is approximately equals to 0.927 radians. But remember, since we are dealing with a complex number in the fourth quadrant, we just attach a negative sign to the argument z. Okay, the principal value is going to be equals to minus 0.927 because the angle is measured in the clockwise direction. Therefore, this is the value we're going to use in the polar form of our complex number. We now need to obtain what? The modulus, which is equals to x squared plus y squared. And we're going to get the square root of 3 squared plus 4 squared. And the answer here is 5. Therefore, our complex number in the polar form will be 5 times cosine of minus 0.927 plus I sine minus 0.927. That's it, as simple as it is. So this is how we convert a complex number from rectangular to polar form given the respective quadrants we've encountered. Now let's look at lastly our last point, how to convert a complex number from polar form to Cartesian form, or what we call to rectangular form. It's a simple game to play because here what we just need is to use a calculator and evaluate the value of the cosine of this angle. So we're going to have 3 times cosine of pi over 3. Use a calculator, put it in radians and convert. We're going to have times a half here plus I. You punch your calculator, you find sine of pi over 3, which is the square root of 3 over 2. You multiply all through by 3, you're going to have 3 over 2 plus 3 square root of 3 over 2i. As simple as that. So what did we learn all through? We learned how to convert a complex number from rectangular form to polar form. We begin by evaluating the principal value of the complex number by using arctan of y over x and using the correct quadrant in which the complex number lies for, and align that argument with the quadrant in which it falls. And after we've obtained the modulus by using the formula square root of x squared plus y squared, and we have seen how to write this complex number from rectangular to polar form. And lastly, we did show you how to use a calculator to evaluate or to transform a complex number from polar form to rectangular form. Once more, thank you for following up to this video. If this video was very interesting to you, feel free to like, comment and share this video, and why not subscribe to this YouTube channel. Thank you. See you in the next video.